Good evening, everybody. Thank you for coming out tonight on a rather rainy evening. It's my pleasure to introduce our speaker tonight, April Whitt, who is the astronomer at Fernbank Science Center. And we have quite a surprise for you tonight. First, she's going to tell you what it's like to be an astronomer. And then we're going to have an opportunity to go inside the star lab. I have already been in it once, and I can't wait to go back. So it's quite a treat. Anyway, thank you very much. And April, take it away.
I don't do real well with microphones. Can you hear me all right? Because I stand right in front of the door. My name is April Whitt, as Ann said. I'm one of the, there are two of us left at Fernbank Science Center, two astronomers. Most of the work that I do is with school groups. Kids come all the time, oh, they want to be an astronomer, they want to be an astronomer, what do I do to be an astronomer? Well, they're the teaching kind, like what I do. They're research kind that spend a lot of time in observatories. This is an aside in the box. A lot of those people need to be in observatories and not out in the general public, so that's why they're research astronomers. There are the kind that write books, write textbooks, or teach in universities. But I get to do a little bit, well, I don't write or teach or anything, but I get to do a little bit of everything. And sort of the theme of this whole presentation this evening is I have been so incredibly blessed with this profession, the fun stuff that you get to do, or that I think of as fun stuff that you get to do. This time is an illusion. We were working on a planetarium presentation. Years ago, there was a planetarium presentation in Rochester, New York. And it was the first time anyone had ever tried to do a comedy show in a planetarium, because a planetarium is like church. You don't laugh in the planetarium, you don't laugh. And so they had put this thing together in sections, and they took everybody who worked in the building, took jokes, astronomy jokes, took them out and told them to everybody they could think of. The ones people laughed at were the ones that were going to go into this program. So they start the production. Everybody thinks this is hysterical. It's the funniest thing they've ever done. By the time the production was finished, nobody thought it was funny anymore because they'd heard it a million times. So they start up, you know, the show opens, theater's dark, stars come on, tape starts, and nobody's laughing. Show's going on, nobody's laughing, and the producers are starting to get really, really worried. And all of a sudden, one guy snickered at one of the jokes, and it was like these floodgates open. People just started roaring, and it was because it was a very serious place, and so you don't laugh in church and you don't laugh in the planetarium. But this was one of their ideas, was the time was nature's way of keeping everything from happening all at once. That I was telling them earlier, working with storytellers. There are a couple of storytellers that work specifically with astronomy stories, and one of the things they were saying was the purpose of storytelling, you know, around the campfire before there were iPods and iPads and little camera things to look at and pictures on walls and stuff. Storytellers told people where they came from, how the Earth got this way, where did the birds come from, how things came to be. And she told us, this is your job now. We are to tell, as best we can, from a science aspect, where things came from. There wasn't anybody around taking pictures 5 billion years ago, so we just have to take our best guess as to where things came from. One of the things she told us was, and you're not doing a very good job, so we better do a better job of storytelling. The best we know where things came from, our solar system anyway, big nebulas of clouds of dust and gas out in space, mostly hydrogen gas. Billions of years ago was when things sort of got started, gravity pulling stuff together. Most of the stuff falling down in toward the center where the gravity was strongest became the proto-sun, the beginnings of our sun. And the leftover bits around the edges, everything's moving. So as gravity's starting to clump things together, and that's, as best we're guessing, sort of where planets came from in our solar system. The neat thing is we're always learning something new. The Earth, when you start off and you can't travel very far because you don't have the time, or you're on a subsistence agriculture society, and nobody has time and enough extra food to stay up all night and watch the sky. You have some ideas. Maybe if you're somebody whose profession sheep herding or something, you might be out during lambing season, you're up all night long, so you might notice some things going on. But keeping track of time the way humans do, a lot of it is astronomical. our Earth. This is a picture from Apollo 17, the last of the Apollo missions that went to the moon. When this picture was, broadcast all over the world, and it was broadcast then because it was television and not the internet and everything that we have now. But people really started thinking, whoa, this is a finite planet. It's not endless. You can't just keep using the water and using the air and burning things. There is a limit to it, which we're so tiny compared to the planet, it's difficult for us to comprehend that. This image was one of the first ones that really got people thinking, whoa, there are some edges to things. Antarctica is down there at the bottom, part of Africa, and the sun up near the top. And that's one of the ways, back up. That's one of the ways we keep track of time. Rotation of the Earth, one spinning of the Earth on its axis, we call that 1 day. For us, it looks like the sun rises in the east, sets in the west. Sun's just out there. We're turning like a merry-go-round. So we're being carried past the sun during the daytime, past the stars at night. So using the Earth as one method of timekeeping, then you can get a little bit further out. Anybody see the moon this morning? Trick question. Totally clouded out, right? This is what it would have looked like. Waning crescent moon, just a little bit of it left. Next couple of days it will be in the new phase and you won't be able to see it at all. The moon was another way of keeping track of time. You've got days going along, and you've got moons. One cycle of moon phases is about a month. That word month is like month with one less O. And the was another way of keeping track of time. Some calendars still use the moon. Some of the Islamic calendars, some of the Jewish calendars. Easter in the Christian calendar is based on the phases of the moon. And so that's another timekeeping mechanism. Something very concrete that you can see, that you can measure. Oh, and another thing, if you have questions, go ahead and ask, because I tend to get really excited and then things just sort of go. But if you have a question, go ahead and ask if you have any. Good so far?
What about Chinese lunar calendar?
Chinese lunar calendar as well. A lot of the...
Are they different from the Jewish or the whatever?
Yes. I think the Jewish calendars, it's 2015 in our calendar, Western calendar. It's a different year in Chinese calendar. But it's interesting because it's a different one in the Jewish year and it's a different number in the Islamic year as well. So depending on where you started from, you get different amounts of time. In 1999, I had a chance to go with the Starlab to Brescia in Italy and work with high school students. Mostly they wanted to learn English, but the guys who were working with them used science as a way of getting them to, and they didn't want to learn British English, they wanted American English for some reason, so we got to go. And observed before, in 1609 was when Galileo's first used a telescope to look at things in the sky, started drawing pictures and writing letters and asking other scientists, did you see this? Or all this published things. This is not a telescope-type observatory because the roof opens up, but we didn't get to use the telescope inside. But it's, I think of it as sort of like what Galileo would have used. He was in a different city, but it was a little building like that. And the neat thing is finding how people kept track of time. This is one of the clocks in Brescia, but if you look at it, it's not 12 hours. There's one hand, an hour hand, and there's 24 hours. The way the gears all fit together, the way it works, it keeps track of time, but not to the nanosecond like we're used to, but just sort of what hour of the day is it, or night, depending on what it is. And I just thought these were pretty, so I took more pictures of them. This one also shows the phases of the moon. There's a dial in the center that shows the way that everything turns and covers and uncovers round white spots. You can get the phases of the moon as well. And this is my favorite. We went to Venice and they were fixing this, so they painted a big canvas and hung it down in front of the clock. So that's a picture of the clock, but they're behind it where all the construction is. They're doing all the repair on it. I just thought that one was really fun. It looks real, three-dimensional. And sundials is another way of measuring time. People figured out before clocks, you just use the sun. And somebody asked me one time, because we say, you guys probably know the concept clockwise and counterclockwise. Children today don't know that because they've never seen a clock face. they've seen those numbers. So they can tell you it's 3:30, but they can't look at a clock and tell you where the hands would be. The big hand here, little hand there. So sundials is where the term, before there were clocks, before clockwise, there was sunwise. This is, the human is the nomad in this one. This is a sundial that's in Wellington, New Zealand. But when I pointed out Antarctica, that's one of the places that I got to go and do cool stuff. And this was using the person as the shadow caster, the nomad, for what time it was. And it's just after lunch, as you can see. But the way that it's set up, depending where you are on the planet Earth, the stick that you use, I mean, you can stick a stick in the ground and watch throughout the day. The shadow falls in different places. If you line up the stick with the North Star, you get a more accurate measurement of time. There's a South Star that one's lined up with, but you can tell time that way, so it's kind of going backwards from the clocks a little bit earlier than that. At the South Pole, time is really an illusion, because I sort of keep track of where the sun is, like it's daytime or nighttime, or it's morning or afternoon. At the South Pole, this was during the month of December, and it's summertime for them, so the sun is up 24 hours a day. It never sets below the horizon. This is around Christmas time. And so the sun appears to move around in a circle, not up and down. Yeah, the only way you can get there, or 20 years ago, the only way you could get there, was on these gigantic prop planes. And the United States, this is the United States base here at the South Pole. Amundsen Scott base. When this was built, it's a dome that was sitting on the ground, and as time went by and snow sort of blew in and piled up, it's banks of snow piled up around there. This is one of the clock faces that I used. Depending on where the sun was in relation to this opening into the building, it was either time to be up and working, or it was time for lunch, or it was time, depending on where the sun angle was for this. There are those little flags that are along the ground. Rather than signs, they use colored flags. If it's black flags, that's a dangerous area. You don't go near it. It's red flags. You can walk there, but be careful. Things like that. This is terrible. I had always wanted to go to the South Pole. Does anybody remember those SRA reading cards? They were different colors. Like, you remember those? Okay. And if you got to maroon, it was a big deal. One of the SRA reading cards. This is so sick. It was about Scott, Robert Falcon Scott, the Englishman, going to the South Pole. And when he got there, Amundsen had got there before him, like a couple of months earlier, and had left this message. The sentence I still remember from that card, because Scott, and it's kind of too bad because it's all stiff upper lip and everything, but he was not properly prepared. He was the only guy who knew how to use the sextant as to where they were. There was nobody else in the base camp who could come and get them, because there was nobody who knew how the instruments worked. So it was kind of bad planning on his part, but the sentence I remember when they came out to find him, in the tent they found the bodies of Scott and his men. And I thought, oh, that is so cool. I want to go to the South Pole. One of the things we did while I was there was, if you take a clear plastic hemisphere, put a crosshair underneath it so that it's right, the cross is right under the very top of the dome. And then if you hold your pen, like a gnome, on the shadow cast, so that you move your pen around to get the shadow casting right on that little spot in the center, you can draw where the sun is around the globe of the sky. So I never actually got 24 hours worth. There was always a couple of hours where I was asleep. But I got most of one whole rotation's worth, and was using that with school kids here. At the time, there was not internet. There was a broken weather satellite that wandered above the horizon twice in 24 hours, and everybody squirted all their data as fast as they could to go from that satellite to Miami, to the internet, to Chicago, which is where we were working from. Now, everybody's got cell phones that work there, but at the time, it was kind of like campfire time. This is the way there's geographically, there's a 90 degrees south pole with a thermometer on it. This is what it looked like when I was there. That's my thumb in the way of the top of the picture, as you can tell. This is what it looks like now. They've got a real fancy one now with a little picture of the Antarctica and everything. And in front of that sign, there's a stick right here. That is the South Pole. stuck geographically South Pole. If you go to the North Pole, the Arctic Ocean is water surrounded by land. So there's just a cap of ice there for the North Pole. The South Pole is land surrounded by oceans. 2 miles deep of ice on the continent, a little bit of snow up on top. And going off in the distance, these flags and these poles, each year on the same date, they figure out where the South Pole geographically is and stick a stick in the ice. As the year goes by, the ice flows, carries the stick away from that geographic point. The year that I was there, I had to help stick the pole in the ground. And it was a brass, I'll show a picture of it later, a brass little tablet thing at the top, and they put a block of wood on top, and everybody who wanted to got to pound the South Pole into the ground. The Harley flag is the guys from the tech unit who were all big Harley fans, so they brought their flag along. Take that picture. And along with the flag in the back. But you can see it was kind of like being in a snow globe that day. The wind was blowing and little crystals of snow were floating, going around, and it was warm that day. It was only 40 below. But everybody, wrapped up like this. But everybody works, 14 and 15 and 17-hour days, 6 days a week. Except at Christmas time, Christmas Eve and Christmas Day, everybody takes off. So that was the day we were putting the pole into the ground. That's what that looked like in 2003. 90 degrees south latitude and flowing freely is what it said. The little dome in the center was the shape of that dome that where the entrance into the Scott Station was. That's the pretend South Pole, the one that all the senators get their pictures taken next to when they go down there. And they, because if you think about, remember the globes when you were a kid and all the longitude lines come together at the South Pole and at the North Pole? So they have, on Christmas Day, they have what they call the race around the world, because you run around all the longitude lines, so you're going around the world, and you go around this South Pole. And you can get around it any way you want to. It's a 3K race. You can walk, you can run, you can ride a bicycle if the lubrication doesn't freeze. You can ride what they call banana boats behind a little ski, little jet ski kind of thing. You can ride behind one of these gigantic tractors. Some of the guys pulled their couches out of the dorms, stuck them on these flat things and rode 3 times around, but it all works. My favorite t-shirt of all times is that one. The race around the world. The reason I was down there was to help with installing this telescope. It's called Spirax, the South Pole Infrared Experiment, or experimental thing. And it was just being put together. And all I did was help pull cables. I didn't work with it or anything because it was just getting put together. But this is what it looked like when it was finally assembled. And because of, if you're looking at like the way that we see visible light that's coming from the sun, have you ever taken a prism, let the sun shine through it, it makes that rainbow? Okay, so it spreads out into a spectrum like that. That's one set of wavelengths of light, visible light. And then there's like X-rays, see what your bones look like. There's infrared, the heat kind of stuff. There's gamma rays, which they make superheroes. There's ultraviolet, okay, sunburn, okay. So infrared radiation, which is really interesting to study, is very difficult to study from the surface of the Earth because water vapor in the atmosphere absorbs infrared from out in space. If you can get above the water vapor, like on an airplane, like I get to do in September, or if you get to the South Pole, which is the highest, driest, coldest place on the planet, it's really dry, it's like 8% humidity there. So fire is a big deal. You have to be really, really careful of open flames and things because the things would just go up. And there's no water to put fires out. So this infrared telescope was being assembled then, and it was going to be looking at the sky and getting infrared data. And this was one of the cool things. In 1994, I don't know if you remember here, because we could see it from here in Atlanta, there was a comet, Shoemaker-Levy 9, it broke up into 20-something different pieces, and the pieces smashed into Jupiter. And you could see from our telescope, and the lines were out the door and out to the street, but you could see the planet Jupiter through the telescope, and then be these dark splotches all over the southern hemisphere, sort of in a line as the different pieces smashed into the planet and exploded and made different gases, so you could see them differently. So they were at the South Pole, the guys were at the South Pole while that happened. It was wintertime, dark for them, so they took all these pictures of the comet pieces colliding with Jupiter. And to me, this is kind of like a photographic negative. Through a telescope, it was a bright planet with a dark spot where the explosion happened, where the comet piece smashed in. This is backwards. This is looking at where the heat coming up from the explosions was happening. So it's the bright spots are where the comet's pieces exploded. Comets, really nice, right? This is Hale-Bopp. Anybody see this one? This was in 1997. And it was really bright for a really long time. The two guys who discovered it, Alan Hale and Tom Bopp, are really good storytellers. Tom Bopp is the one on the left, and he was talking about, he was in Arizona, and it was in March, and it was raining, and it never rains in March in Arizona. And there was this one clear weekend going up. He's an amateur astronomer. So he and a bunch of his friends were going to go out observing. They'll take their telescopes and everything. And you go out and get set up before the sun goes down so that you can see what you're doing. And then once it gets dark, then everybody's doing all this observing and everything with all their different telescopes looking at all different things. So he's ready to go, and his car won't start. He has to go borrow his father's car. This guy's older than I am. And he has to go borrow his dad's car so that he can get to this place because he really wants to do this observing. Well, his dad has one of these really fancy cars with the headlights that don't turn off. So you're coming into this dark sky site. People are screaming and cursing because he's got these lights on. It's ruining everything. So he finally finds a place to park, gets himself set. And then he goes, and they were doing the observing, and they were looking toward a part of the sky, Sagittarius. We can see it on the Starlab if you want to. And he saw this thing that he was pretty sure it was this little fuzzy thing, and he was pretty sure it wasn't a star that was on regular charts. So he's looking at the star charts, can't find them. So, does somebody else has some better charts. They go digging through this guy's trunk of his car, pull out this stuff. Nope, and then he observed it like half an hour later, and it had moved a little bit. So it's not a star, this is something that's moving through the solar system, so it could be a comet. And if you discover a comet, you can get it named after you. This would be so cool. So he said, okay, so this is 1997. This is before, there are cell phones, but they were out in the middle of nowhere. There was no cell coverage where they were. So they jump in some car, drive to this little drugstore that has a payphone, but they don't know what number to call. They're supposed to call the Smithsonian Astrophysical Observatory, is where you officially send in your information, and then they check out all the coordinates and everything. So he doesn't know what number to call. So they finally figured out, well, okay, it's in some place, it's in Harvard, so they'll call the telephone operator at Harvard. Well, she's never really heard of it. She doesn't know what this place is. So, oh wait, somebody's got a Sky and Telescope magazine. Flip, flip, flip. Okay, here's a telephone number. So they call that number, and they get an answering machine. Oh man! So he leaves a message, and then he goes from the drugstore. He sends a Western Union telegram to the telegraph office at Harvard because you got to be the first one to get your name in so that you can get get named a comet after you. So he's telling this whole story, and then they came home. It's like 3 in the morning. He goes to bed. The next morning, he's still asleep, and the phone rings, and his wife calls, "Honey, the Harvard something wants to talk to you. You want to talk to them?" And he said he got from the bedroom to the kitchen without touching the floor and answered the phone. He was, is this Tom Bopp? Yes, it is. Did you report a comet? Yes, it is. Well, congratulations. 2 people have reported it, so your name gets on this. So that was his wonderful story. Alan Hale, professional astronomer who has been looking for comets for years and never found anything, is out on his driveway with this big telescope he's pulled out of his garage. He's looking at stuff. And there was another section of the sky he wanted to look at, but it wasn't high enough up to see yet, so he'll just wander around in Sagittarius. Well, oh, here's this thing. He sent 3 emails with updated coordinates before the telegram got there. The guy who was there, Brian Marsden, was saying, he was laughing. Nobody sends telegrams anymore. They all go by internet or whatever. So the 2 of them, both their names are on that comet, and it was a really nice one. It's got a really long orbit. Like Earth takes 1 year to go around the sun, and Mars takes almost 2 years, Jupiter about 12 years. Halley's Comet, anybody know? About 76 years. Okay, so like from 1989, 89, and then 2061. So it's 70-something years in between. This comet takes thousands of years to go around the sun once. But this is Pepe I, one of the pharaohs of Egypt, as his pyramid in Saqqara, and there is a hieroglyph inside. Oops. Okay. Oh, man. There's a hieroglyph inside that's NHH is the hieroglyph. But
It's on the right side of the image.
Oh, there it is,
Yeah,
down there at
it's
the
right there.
bottom? Okay, and it means long hair. And it's possible that was the comet that they saw because they look like big hairy stars. So it's possible that that comet had been seen, 3000 BC and is now on its way around again. So that's kind of cool. And then the Chinese did comets too. People who have, cultures that have been around for thousands of years, watching and keeping track and writing things down and keeping records. This was pre-telescope as well, so it was visual observation and all different kinds of tails, obviously, that you can see on this. And there are thousands of years of records, which are really nice when you're going back and looking for something that was, well, its orbit seems to be about this many years. Anybody got a record of it? Look at that. So you can find the records of it. The instruments they used pre-telescope, this is a quadrant, and you can measure the angles of things. That's one of the ways you can tell if you're looking at a particular set of stars, and you can see, okay, this star is about as far apart as that star, and then you can draw a little map. And then, oh, here's this odd star that's just sort of wandered into the picture. Maybe a comet, maybe a new planet. And this thing is huge. I don't have a person standing next to it, but I would come up to about the edge of the rock there. About this tall. That would be me. It would just keep you up higher than that. And armillary spheres, another way of keeping track of time. The equator of the Earth, project that out onto the sky. Project the north and south poles out onto the sky, and then watch where do the planets appear to move against those lines. Where do the different constellations at different times of year appear to move? Where does the moon move along? So all of that information was already being collected before there were telescopes. Really great observers. Sorry?
Where are those located?
Those are in Beijing, in the ancient observatory. This one, and this is sort of an experiment. Look on the left-hand side, and there are a couple of lines that seem to be going up. There should be, it looks to be like 3 stars kind of in a row. Here. Kind of like Orion's belt. We're going to be looking for that in the Star Lab as well. Because this is from the southern hemisphere, it looks upside down in the way that we would see it in the northern hemisphere sky. But again, star charts and constellations from a long time ago, keeping track of things, really useful. And then we get into sort of modern day stuff. The planet Mercury, the last time it was visited by a spacecraft was in the 1960s. A Mariner spacecraft flew past twice. The way its orbit was shaped, it looked at the same part of the planet twice instead of different parts of the planet each time. But in 2004, the Messenger spacecraft launched from Earth. And it's kind of interesting because NASA loves acronyms. Messenger of the gods. Mercury. Mercury, surface, space, environment, geochemistry, and ranging. Mercury. Messenger. It took some doing, but by golly, we got an acronym. This is its last month. It took 9 years to get there, well, almost 9 years. Got there in 2011. Went into orbit around Mercury. Mercury is really, really close to the sun, so there are all kinds of challenges with getting spacecraft toward the sun. Gravitationally, easy. The sun's pulling, no problem, except that if you want to get to a little teeny planet, You're gonna have to slow your spacecraft down, a couple of times around Earth to slow down, a couple of times around Venus to slow down, a couple of times around Mercury to slow down, and then finally into orbit around Mercury. It took, well, it was 7 or 8 years of that doing. 8 billion miles is what it's traveled so far in all of its work. The sunshade that's on the back of it, that sort of curved thing, is what stays between the spacecraft and the sun all the time, so its orientation changes so that that's all that keeps the instruments inside there, all in the shade of that sunshade. And it, I have a piece of it. It feels like woven dental floss. It's kind of waxy feeling, but it's a ceramic type of fabric. And it does a fabulous job. You kind of blow torches on the other side of it, and it's still a nice, 68 degrees inside the sunshade. The 2 solar panels sticking out on each side to make electricity. You're getting closer to the sun. 3/4 of those panels are mirrors, reflecting light away. You don't need as much light, as much energy as is coming from the sun when you're that close. But the numbers are pretty amazing. And this is, as I said, this month, the month of April, this is the last month of life for that little spacecraft. On the left-hand side is the Mariner picture that was taken in the 60s. On the right-hand side is one of the close-ups from the Messenger spacecraft. Incredible detail. The neat thing is every time you get up close and start looking at a planet or a comet or at anything up close, there's way more detail than you thought there would be. There are all kinds of, like this sort of a bright crater with rays coming out of it. It's actually a color image of that planet, and it's mostly gray looking, but if you use false color on it, you can see the depths of craters and the heights of mountains and all that good kind of stuff. So this is a relative picture. Planet closest to the sun, Mercury. Planet, well, if you call it dwarf planet, farthest from the sun, Pluto. In 2006, the New Horizons spacecraft lifted off. This is the fastest spacecraft ever in history. Anybody know how long it took the Apollo astronauts to get from Earth to the moon? 3 days? 9 hours for the spacecraft to get to the moon. When the Galileo spacecraft was sent to Jupiter to be in orbit around and take a lot of pictures, it took 9 years for the spacecraft to get out there. It took 13 months for New Horizons to get to Jupiter and slingshot its way around. It's going really, really fast. And this is a teeny thing. It's about the size of that grand piano. It only weighs about 1,000 pounds. And this July is when it gets close. This is the best picture we have of Pluto right now. This was taken with the Hubble Space Telescope.
Oh, sure it is.
Sure. This is the
of course
best
it
we've got. Okay, actually, there's a little bit better one a little bit later on. But this is Pluto at the best. By golly. There are dark spots. There are bright spots. Yeah, okay. So, at the same resolution, see if you can guess what that thing is.
Earth.
Earth, maybe. That's our moon at the same resolution. And you've all seen the moon better with just your eyes, right? Because it's close by. Okay, so when New Horizons gets to Pluto, it's going to be able to see one little square, one little pixel is just 5 kilometers. That's an easy race, okay? Foot race. But this is what the moon looks like at that resolution. We're going to be able to see Pluto that well. The thing of it is, as the guys were saying, it's gone 3 billion miles, 9.5 years this thing has been flying. It's going for a target that's 60 by 90 miles, and it has 100 seconds to get there, get its pictures, and keep going. That's not easy. But that's the cool thing. Engineers are incredible people. Okay, there's our best picture right now. Yesterday, we were 3 months out, 90 days till we get to New Horizons. That's Pluto is the big dot. The other dot is Charon, its big moon. The two of those things are like a double planet. The same faces of them stay together. They orbit. One rotation of Pluto is one revolution of the moon, essentially, and they're phase locked together, so the two of them see each other all the same time. The back side of Pluto has some reflected light from Charon, so we should be able to see a little bit of the back. It's pretty dark by the time you get out there. I mean, it's really, really far away from the sun. Earth is 1 astronomical unit, away from the sun, about 93 million miles. Pluto is almost 40 astronomical units. So it's taken a long, long time to get out there, and July 14th and 15th, it goes by, and then the funny thing is, it's got this, the way that it keeps, collects data, it's been collecting data the whole time. And because it was such a long trip, most of the year it would be in, they called it hibernation. You just put the thing to sleep, turn off your lights, go to sleep for 12 months, 11 months. And then they would wake it up once a year. Everybody working? All the cameras working? Yes. All this working? Yes. Solar panels? Yeah. No solar panels because you're that far away from the sun. The sun doesn't work way out there. So it's a little plutonium generator. And everything worked. In July of last year, they sent signals that tricked the spacecraft into thinking it was July of this year and had it do a complete run through all the science. Turn like this, take this picture, now to this orientation, take this picture, now take this measurement, now look over this way, take this measurement. Worked flawlessly. So we're really, really hoping that in a couple of months, everything will work flawlessly. The pictures that came back were just sort of these dots because there wasn't any planet there to look at last July. This next July is going to be awesome. The planet Saturn also has a spacecraft around it. This is one of those time-relative things. In 1997, when the Cassini spacecraft was launched, this thing is huge. It's the size of a school bus. It was the last big planetary exploring thing and last big planetary exploring thing that NASA launched. It has the sort of dish at the top is how it sends information back and forth. This one took about 7 years to get to Saturn. I was working with second graders at the time, and we were talking about this spacecraft, and it was going to go, it was going to be in orbit around Saturn, it was going to send back pictures of the rings and the moons and all this stuff. And what I was able to tell them was, when you guys are in high school, second graders, high school, that's when the spacecraft is going to get to that planet. When you're 8,
That's a long time.
that's half your life. I mean, it's a long time till you get to high school. And with the kids that I work with, you always say when you're in high school, not if. When you're in high school and when you go to college. And so this is a bunch of numbers from Cassini as well. Not quite so many miles, but terabytes of data that have come back from this thing. 7 new moons that we didn't know were there before until we got up close and were able to look. Just all kinds of interesting stuff. But my very best favorite picture that it took several years ago is this one. The spacecraft is looking at Saturn, and the sun is on the opposite side. So the rings are backlit. This is light coming through the rings, but this is the really cool part. See that little dot right there? That's Earth. That's us. That's all the good stuff on that little teeny speck. One of the things about astronomy is it keeps your mind straight. Yeah, it's terrible the remote isn't working on the TV. What the heck? You're way out there, you're nothing compared to what's going on out there. Or, this is what I ask the kids a lot. Here we are standing on the Earth, we're looking out at the stars. They're huge. And here we are, and we're really tiny. Are we really tiny? And they're really huge? We can think. We can learn things, we can build things, we can discuss things, we can talk about things. Stars just burn, which is cool because you need them. But I think that's pretty awesome. Any questions? Yes?
Oh, I see like a little yellow dot at the bottom of Saturn. Is that the sun?
That's the sun leaking through the atmosphere, yes. Saturn is not stiff like the Earth is, it's not solid, it's just gases. So the sunlight can get through the atmosphere of Saturn, it's kind of the bright ring around the planet, and then through the gaps in the rings as well. Yeah.
What kind of atmosphere does Saturn have? What kind of atmosphere?
What kind of atmosphere? Mostly hydrogen, a little bit of helium, a little bit of methane. It's the same stuff that stars are made out of, but it's not big enough to start reactions, so it can't make itself into a star. The rings, there's still a lot of information and guessing about where did they come from. Did they form at the same time the planet did? Was it a moon that got too close in the Roche limit, it broke apart, made a bunch of rings around it? Are they captured from other dust that's around in the area? And you can see all around the edges looks like comet tails. There's a lot of dust. When you look through a telescope, you can see sort of 3 sort of basic rings on Saturn. And I remember as a kid thinking that they were like a phonograph record. Nobody knows what a phonograph record, like a CD, okay? And it's stiff, but they're not. It's like being in a snowstorm, except some of them are snowball size, some of them are boulder size, some of them are a centimeter across. So they're all different sizes of specks, mostly ice. They reflect a lot of light, which is why it's easy to see them. Jupiter has rings, Uranus and Neptune, they all have rings, but they're really dark, more dusty rings. But the dust that's way out in space, that's still part of that whole Saturnian system. That's all I got. Any questions? Thank you very much.